Hello students, welcome to this video tutorial on an introduction to algebra tiles. So please make sure you have open your Google slide, an introduction to algebra tiles student version, and here we go. When using algebra tiles, there are 6 kinds of tiles you will be working with. The positive and negative integer tiles, which you are familiar with from our integers unit. The positive and negative x tiles, here they are, positive x and negative x. And the positive and negative x squared tiles, we have positive x squared and negative x squared. Okay, so what we're going to be focusing on is we're going to be representing algebraic expressions and equations using algebra tiles. So on slide 3, at the bottom of slide 3, we have our algebra tile bin. So we have our various algebra tile manipulatives. We have our bin of positive integer tiles, negative integer tiles, positive x tiles, negative x tiles, positive x squared tiles, and negative x squared tiles. All right, so let's start with some very simple examples. So in example 1, we have positive 4. So I would like you to construct this algebraic expression using these tiles. So for example 1, positive 4 is simply 4 positive tiles. All right, hopefully you got that answer. All right, looking at example 2, we have an algebraic expression of negative 2. So please build this algebraic expression using your tiles. All right, example 2, 2 negative integer tiles. All right, let's go to example 3, 2x, 2x. So if you have to look back on slide 2 to remember what an x tile looks like, that's what it looks like. So we have 2x, and it's positive x, so we have to use our positive x tiles. So here we go. 2x, this is how we represent 2x. Now, keep in mind that these tiles, these algebra tiles, are completely different from our integer tiles. All right, let's look at example 4, negative 3x. So we have to be drawing from this bin right here, negative 3x. Now, when you're building these algebraic tile solutions, you can stack your tiles vertically or line them up horizontally, whatever works for you. Okay? All right, let's go to the next slide. Example 5. So we have a combination of things here. So let's look at one thing at a time. Let's look at the negative x first. Let's look at this part first. Okay? So let's see if I can highlight that. All right, so negative x. So let's bring over a negative. So that's our negative x. And let's look at the next part of our algebraic expression, negative 3. Okay, well that's pretty easy. We bring over 3 negative tiles. All right, so this tile diagram represents negative x. We have a negative x and negative 3. Okay, when we're building algebraic expressions or equations, we always want to put the x's in front of the integers. The x's in front of the integers. All right, let's go to example 6. 3x plus 2. So focus on one thing at a time. Focus on the x's first. So we have positive 3x. So we have our 3 positive x's, and then we look at our integer, we have plus 2, positive 2. So bring those tiles over, please. Okay, so here is the tile solution or tile diagram for the algebraic expression 3x plus 2. All right, let's move on to example 7. Again, let's separate these terms. These are called terms. So I'm first going to look at negative 4x. So please build that part of the diagram, negative 4x. So I've got my 4 negative x tiles here, and then I've just got positive 4 left. So it's very important that you keep your tile diagram solutions very organized. I've got my 4 negative x's together, clumped together or grouped together, and I've got my 4 positive tiles grouped together. This idea of grouping is very, very important. I'm going to use that word over and over and over again. Okay, let's go to example 8. Example 8 looks very simple compared to the other ones. So let's bring over our positive x. If there's no sign in front of it, then you have to assume it's positive. So we have our x. It doesn't need to be grouped together because there's only one of them. And then we have 5 positive tiles. All right, so I've got my 5 positive grouped together. I've lined them up horizontally, but if you wanted to stack them kind of in a smaller group like this, that would be fine, as long as they're all in the same area. This is what we don't want. We don't want like a random positive tile over here. We want to keep like terms grouped together. Like terms means they are the same. Okay, let's proceed to the next slide, example 9. So from these questions and on this slide, we're going to introduce the last element, these tiles over here, the positive x squared tiles and the negative x squared tiles. So if we look at example 9, we have something different. We have a different term here, so I'm going to use a different color. So x squared. All right, so x squared is this big tile over here. Let's push it all the way over. Then if I look at the next term, it's different. This is positive 2x. Now I used orange on the previous tile, on the previous slide I mean. So positive 2x. Do you remember what those tiles look like? So let's bring over 2 positive x tiles. And let's group them together, put them in the same area. And then finally, we're left with an integer tile, negative 1. Okay, let's grab a 1 negative integer tile. So when we're creating our tile diagram solutions, we want to have the x squareds first, then the x's, and then the integers. This is very important, especially when we get into grade 8 and grade 9. We have to put the x squareds first, then the x's, then the integers. All right, let's look at example 10. Now, you notice that I've changed the order around. So what I always like to do is I always like to look for the x squareds first. So in this case, the x squareds are at the very end of the algebraic expression. So I'm just going to highlight those in my blue color, and I'm going to focus on this part first. So negative 2x squared. So negative x squareds are these tiles. So I'm going to bring over 2 of them. Then what I want to do is, when I look at my question, I want to look for the x terms. The x terms, which I've been highlighting in orange. So we have negative 3x, okay? So you know how to bring over negative 3x. And finally, the last part of our algebraic expression is the integer, positive 3. Okay, so this is the algebra tile diagram for negative 3x plus 3 negative 2x squareds. I want to have my x squareds first on the left-hand side of my diagram. Then I want to have the x's, and then I want to have the integers at the end. All right, let's go on to example 11. So again, as I look at this algebraic expression, I want to look for the x squareds first. So I find the x squareds at the very end, positive 3x squared. So I'm going to highlight those in blue. And I'm only doing this because if this was on a piece of paper, I would just circle them because that's what I'm going to focus on. So positive 3x squared. So we're going to use these tiles. And I want to put the x squareds all the way on the left-hand side. So that's why I kind of focused on them first. Then I want to look for the x's. So in this case, we have plus 2 or positive 2x's. I'm going to highlight them in orange. So positive 2x would be these tiles right here. And then finally, I'm going to focus on my integers, negative 4 integer tiles. Okay, so this is the algebra tile solution for the algebraic expression negative 4 plus 2x plus 3x squared. I want to have my x squareds first on the left-hand side of my diagram. I want to have my x's in the middle, and then I want to have my integers on the right. Let's go to example 12. Okay, so let's look for my x squareds. So I've got an x squared here. Going to highlight that in blue. And I've actually got another x squared here. So let's see what that's going to look like. All right, I'm going to highlight both of these. Okay, so negative x squared. Okay, so that's easy. Let's bring over a big negative x squared tile. And then let's look at the next term. The next term is negative 2x squared. Okay, so that's just two more of these negative x squared tiles. So when we group them together, we can actually see that this is actually 3 negative x squareds, or negative 3x squared. Okay, let's look in our algebraic expression. Let's look for any x's, and I see an x here. It's just a lonely positive x. I'm going to highlight that in orange. So positive x is one of these tiles. And then I'm left with negative 2 integers. Okay, so this is the algebraic tile solution for the algebraic expression 4x minus x squared minus 2x squared minus 2 plus x. Oh, actually, I forgot something here. I apologize. I totally did not see this positive 4x. So let me move my integers over because I'm going to need more room here. Okay. All right. So I need to bring over 4 more positive x's. And that's the most common mistake, is sometimes you forget a term. And I apologize for that mistake. Perhaps you didn't make that mistake when you were building your tile diagram solution. All right, so let's see if I got it right now. Negative 3x squared. I've got 5 positive x's, and I've got 2 negative integer tiles. Okay, let's go to the next slide. So as we're working through these problems, they're getting a little bit more complex. Okay, let's look at example 13. Now you see that we've got a lot more room for example 13, so there's probably going to be a lot going on here. Okay, so let's look for our x squared terms. So I find one right at the beginning. I'm going to use blue for that. And then I find one right at the end, a negative 3x squared. So I'm going to use blue for that. Okay, let's start there. So positive x squared. And then we have negative 3x squared. Okay, so let's bring over 3 of these. Now you notice how I put the negative x squared below the positive x squared, and hopefully you're realizing why. So that's my first negative x squared, and here's my second, and here's my third. Now a positive x squared and a negative x squared create something called the zero model. So what we want to do is we want to circle them. So let's go up to the shape tool here and choose shapes, and let's choose like a rounded rectangle. And what we're going to do is we're going to draw a loop around that zero model. Now, unfortunately, it covers up those tiles. So what we have to use is we have to use the fill color, and we have to make it transparent. And then I want to change the color to red. And I just want to make the line a little bit thicker to 2 times. Okay, so I've circled a zero model. If you remember back to your integers unit, you will remember what we're going to eventually do to a zero model. Okay, let's go back to our algebraic expression. Let's look for the x terms. So I've got a negative 3x here, and I've got a positive 2x here. Okay, so let's bring these over. Negative 3x. So I've got my negative 3x. Now I'm going to focus on this term, positive 2x. So my positive x's are here. Now, I stack them underneath the negative tiles, the negative x tiles, because I notice that there are zero models here. There are 2 zero models. So let's go through the process of circling them. Let's use the shape tool. Choose shape, choose the rounded rectangle, draw a loop around those 2 zero models. Go to the fill color, transparent, line color red, line weight 2 times. So I've got another zero model here. Now I'm not finished. I've got 2 positive tiles here. So let's bring over 2 positive tiles. Okay, so we know from our integers unit that whenever we see zero models, what we want to do is we want to take them away. So I'm just going to put a little arrow here to show that that zero model is going to be taken away. And then I could put another arrow up here to show that these zero models are going to be taken away. So if we take away this zero model and these 2 zero models, what's going to remain? And that's going to be our answer here in step 2. So let's recreate what remains. So we have 2 negative x squared tiles. So let's bring up negative 2x squared. What else do we have? We have a negative x. So let's bring over a negative x. And what's the last thing we have remaining? We have two positive tiles. Okay, so this is our solution. This is what happens when we do something called simplifying. Simplifying is if we have a very complex algebraic expression, we take away any zero models which might be present, and the actual algebraic expression is simpler than it was. Remember, we always want to put our x squareds first, then our x's, then our integers at the end. Okay, so let's look at example 14. What I'm going to do is I'm going to highlight all the different terms, and I'm going to try to give you a head start. So I want you to see if you can solve this on your own. So I'm going to highlight first the x squared terms in blue. And then I'm going to highlight my x's in orange. Remember, we cannot combine or make zero models from x squareds and x's. They are totally different things. All right, so I've got two terms with x squareds. I've got two terms with x's, and it looks like I have two terms of integers. All right, I'm going to give you a head start, and I want you to start building step one. So I've combined my negative 2x squareds and my positive 3x squareds, and I notice that there are two zero models created. So I've stacked them on top of each other. So now I'm moving on to my x terms. So when I organize and build my x terms, I notice that I have one zero model created. All right, now I'm on my integers. I'm going to start with negative 3. And then I have to build positive 4, and I'll do that underneath. And as I build my integers, you should notice that 3 zero models have been created. Okay, so here's my complicated algebraic expression, but it becomes much more simplified when I take away the zero models. So I'm not going to add the arrows here. I just know that these groups of zero models have to be taken away. And when we take them away, we're going to draw what remains for step 2. So for step 2, I've got 1 positive x squared remaining. And in terms of my x terms, I have a positive x remaining. And in terms of my integers, I have a positive 1 remaining. So you see how much more simple this algebraic expression has become once we've taken away all the zero models. So hopefully you got this answer. Again, I want to put my x squareds first, then my x's, then my integers. Okay, let's go to the last example, or the last screen. Okay, so something different. Whenever we see an algebraic expression that has an equal sign in it, it is no longer an algebraic expression. It is now an algebraic equation. Equation means equal sign. So when we build these diagrams, we just build the left side of the equation, the left side of the equal sign, and then the right side of the equal sign separately. Treat them as two different questions. Okay. So let's look at the left side first. There are no x squareds. So I'm going to focus only on the x's. So I'm going to highlight these for you. You can start working on them. When I look at the right side, I'll notice that there are no x's, but there are x squared. So I'm going to highlight those in blue. Now please notice that I have provided the equal sign here. So I want you to build the left side of the equation here and the right side of the equation here. Now to save space, because there's really not a lot of space, I've stacked my positives together, but I've stacked them underneath the negative x's so that I can recognize zero models. And I can see that there are 2 zero models created on the left-hand side. Now I'm going to concentrate on my integers on the left-hand side. I really don't have a lot of room. So I've got my 3 negative tiles, and I'm going to add my 5 positive tiles. And I'm going to stack my last 2 positive tiles underneath because I recognize that there are 3 zero models created. So that takes care of the left-hand side. A little bit messy just because it's a little bit crowded. Okay, so now I'm going to focus on the right-hand side of the equation, and I'm going to focus on my x squared terms. I've got my 3 positive x squareds. I'm going to bring over 2 negative x squareds. And you should realize that you've got a couple zero models. And then I'm going to focus on my integers. And I know I don't have a lot of room. I'm going to start with -2. And then I'm going to build my +3. Now, as you do that, hopefully you realize that there are 2 zero models created with the positive and negative tiles. Okay, so this equation is going to get a lot simpler. So let's look at the left-hand side here. So what's remaining? We have 2 positive x's. So let's bring over 2 positive x's on the left-hand side of the equation. And then we're left with 2 positive tiles on the left-hand side. Okay, let's look at the right side of the equation. What's remaining after we take away all these zero models? Well, we have a big positive x squared, and then we have a small positive integer. Okay, so you see how this equation is much more simplified than what we started out with. Okay. All right, so what I want you to do is I want you to try this one. I want you to press pause, and then when you've got the answer, I want you to press play again and see if you got the same answer I did. If you're running out of tiles, all you need to do is you can click on a tile, and then you can go to Edit, Copy, and then Edit, Paste. I have a feeling you might be running out of tiles. Okay? All right, try to keep things neat. Remember, try to have your x squareds first, then your x's, then your integers. All right, I want you to press pause now. All right, I'm back here. That took quite a while. It was a crazy, crazy tile diagram. But once we simplified, the answer is actually very simple, isn't it? So hopefully your answer matched with mine. Let's go through it. On the left-hand side, I created 2 zero models with -2x and +2x. And I created another 2 zero models with -2 integers and +2 integers. On the right-hand side of the equation, I created 4 zero models with 4 positive x squareds and 4 negative x squareds. I created 2 more zero models with -2x and +2x. And what remained on the right-hand side was 1x plus 3. And what remained on the left-hand side was positive x squared plus 1. So again, we want to put the x squareds before the integers and the x's in front of the integers. All right, so we just went through a big long lesson on how to use digital algebra tiles. Thanks for watching. Bye.